Welcome to Special Data Hub. In this video, I'm going to show you how you can perform supervised land use land cover classification of Landsat images using QGIS. So first, we'll download our Landsat image from USGS Earth Explorer. Feel free to use the contents in the description of this video to skip to any point which you are most interested in. In the description of the video, there are links to a number of videos which you can check out, a more detailed description of how you can download images from the USGS database, and then how you can import these images into QGIS. So here, quickly run through, you can upload a shapefile or a KML file, or zoom and pan to your area of interest and just click until you are satisfied. So then you set up your cloud cover to probably less than 90%. When selecting your data sets, choose Landsat for what we are doing here, Landsat-8, and then you can choose to set up any other additional criteria as described in that video. Otherwise, you move on to selection of your results. One of the most important features here is the footprint. Clicking on the footprint helps you see if the image you are to download covers your area of interest, as you can see right now. Same with this. Unlike this, you can see this one, see our area of interest here, but it doesn't cover it completely. So if I'm to download, I'll want to lean towards any of these ones. Click on the download button and proceed. So I already have mine. When downloading, you can choose to download only the first 7 bands, since that's what we'll be using in this analysis, and as well as the mtl.txt file, since we also need it in converting to reflectance. Or you could download the whole package so you have everything at once. So I already have my study area here. To import our Landsat images, we can use the data source manager or use the browse panel. If you want to learn that, check that in the description of the video. I'll just drag and drop my files here. Okay, let me have my shape file on top. As you can see, my image covers my shapefile perfectly. Alright, so I want to perform analysis, but I don't want to perform analysis for the whole image, for the whole Landsat image. So I want to clip it by my shapefile. If you do not have a shapefile too, there is a way around it for you. So simply go to, well, first let's download our SCP plugin, semi-automatic classification plugin. So go to plugins, manage and install plugins, and on the all search you can just type it semi-automatic and it comes out. Make sure it's ticked here after downloading. So you click on install, download and install, and this is the home page of the plugin. Make sure to check it so that it shows here. And then you go to your plugin. Let's go to the band sets. Let's close up all of these. Clear. That's just something I was working on earlier. So you go to your band sets to include your images, your Landsat images in your band set. Just refresh and they all show here. And then to add them, click, you can Control A, or you click them individually and plus. They're added to band set 1. So we want to clip our raster by the vector. So we go to pre-processing, clip multiple rasters, select input band set. Remember we had our input band set as band set 1. So in case yours is not working, be sure to confirm that you have just band set 1 or the band set number. And then the output name is clip. You can change it if you want. It only means that all the images that will be outputted will have clip, then the Landsat name. And then if you have coordinates which you are clipping by, you type them in here. Or if you are clipping by the map canvas where you just click, you can use this to add coordinates from the map area. But mine, I want to clip by vector, a vector file. So when you just check this box, refresh this point here, and it will show you the vector file which you want to use. And when you're done with that, you click on run, select the folder which you want your files to be saved. If you've not already done this, you can now go on to create a new folder, probably name it clip or something you could know it as. Selected my folder and then I'll let it run. Perfect. So that signals that our job is done. You can minimize or close this, and then you see that our images are added here. So go on to delete the original Landsat images since we no longer need them. Right click and remove layer. Someone wants to sneak in. Alright, so we can open up band set again. When you refresh, it shows the new images that are there, and then you can delete the entries here and add. Okay, click all and add. Be sure to set your wavelength quick settings to Landsat-8 or Lulc, and then your units to micrometers. So once we are done with that, let's convert the images to reflectance. So you click on Landsat, select the file where your images are saved, select the folder. Remember, I saved my clipped files, my clipped images to this clip folder. Select my folder, and that MTL file I told you to download earlier, go search for it. It's, if you downloaded the whole package, it's in the folder where your Landsat images were stored. So I select my file. You can see it has the mtl.txt extension. Open. I'll check this apply DOS1 atmospheric correction, and then once we're all good, we run. Once again, you create a folder, name it reflectance or something you can remember. This is mine. Perfect. So you can close and minimize this again. Now let's take off our clipped images. remove layers. There is one more. Remove layer. The ones that have been converted to reflectance, you can see they have an RT prefix before the clip. So now we will check back on our band sets to refresh it. Check your band sets. Okay, it has automatically been, okay, it hasn't. Let's refresh. It now has only these ones. It automatically creates a new band set named band set 2. Check the order of your images. If it is in the order of 1, 2, 3, 4 to 7 for the band sets, as you can see mine here, band 1, band 2, band 3, band 4, band 5. If it is not, do well to order them accordingly here, or using any of the arrows. So ours is fine here. You can add your SCP toolbox if it's not already added. So when working with Landsat images, one thing we should be sure of is that Landsat collects images at different bands and at different wavelengths. As we can see on the screen, there are 7 bands which we are working with. Landsat-8 collects at 9 bands, 9 different bands. But the 7 which we are working with, the coastal or aerosol, the blue, green, red, near infrared, short infrared 1, and shortwave infrared 2. All of these have different wavelengths in micrometers that Landsat takes these images. So the different wavelengths, different features on the land, on the earth, reflect light at different wavelengths. That's the importance. So a combination of the different wavelengths, the different bands, will give us images, classified images that show, that reflects better properties, better features, the certain features on the earth better. For example, the 432 is the natural color image. It typically replicates the closest thing to what our human eye can see on the earth. Yeah, the healthy vegetation, unhealthy vegetation, and all of that. Let's try some of them. I already have mine here, but the way to type it, it's simple: 4-3-2. And click on enter, and then you see this virtual band set 2. If it's not at the top, do well to drag it to the top and work with it that way. So we see it showing the healthy vegetation, the typical agricultural area, the urban areas, and all of that. We can use the 764. We can use the 764 to show the vegetation in different shades of green. As you can see, there is a difference between this vegetation and this, and also this. So we can, if we are creating our training input, we can call these areas forestry, we can call this area vegetation, we can call this area agricultural areas, or places like this, agricultural areas. Just like that. We can use the 543 because chlorophyll reflects near infrared light better. Our 543, do I have 543 here? Okay, let's type it in. 5-4-3. As you can see, it's right now. So all of these, we can play around with the different band combinations which is shown on that last slide, and we can use the 562 or the 5644, identifying the water bodies and the built-up areas. This is 564. You can see the built-up areas in blue, We can see water bodies. We can see water bodies. We can see different classifications. So let's just create our training inputs. If your SCP doc it's not here after installation, you can always remove it if you want to remove it. Yeah. So to dock it, right click here and check on the SCP doc panel, or you go through view, panels, and SCP doc panel, whichever one works for you. So let's create a training input. If you're using an older version or a more recent version in the future and you don't see these features exactly the way it is, be sure to know that it's just somewhere around. They typically change sometimes with versions. So training inputs, create a training input. I want to save my training input in this folder. So I set file name training inputs, save. So our macro class should be one macro class ID. So there are different classes, the macro class and the micro class and the class. So the macro class, let's say we have a macro class of green vegetation. Under this green vegetation, we could now have forests, we could have agricultural areas, we could have, or maybe just like that. Then a different macro class to show water bodies. Under water bodies, we could have rivers, we could have oceans, we could have ponds, depending on what we can identify in our study area. So that's just the way it works. Then for our micro class, okay, let's just stick with water bodies. Let's identify the water bodies. We'll use the 564 to identify water bodies. To be sure of what we are doing, we could also try the 432 to see what it identifies as water bodies. As you can see, these ones inside are different from these ones outside. And that's why it's important to try different band combinations. If you go back to 564, you almost be deceived into thinking that these ones are also water bodies. Yes, but it's really not realistic to have water bodies in different patches like this. So always try out different things and know which is best. So to create a training input, we've created a training input. Then let's add a region of interest, create ROI polygon. What you do here is just you click 1, 2, as many as possible, and then when you are done, right click, it selects this polygon. So all we are trying to do here is training our system to know that yes, this point is a water body. So when it identifies pixels that looks like this, any of these selected pixels, it classifies it as a water body. You can create more than one region of interest, just that when you click, I don't want to get into the green areas, click. When you are done, you hold down Control and right click. That helps you save your previous selection. So when you are satisfied, you can create as many as you want. When you're satisfied, you click on Save Temporary ROI to Training Inputs, and it simply saves. Alright, so we can create a new macro class. Let's call it and give it an ID of 2. Let's say vegetation, call it forests. Our region of interest, we'll select this, 2, 3. And when we're done, we right click. Let's also select these darker areas. When we're done, hold down Control and right click. Hope we don't have something that's so much different. Let's select these areas. Hold down Control and right click. If you're done with that, we'll click on Save. So now let's create a settlement region. Settlements. Can call it here built up areas. Band combination. Let's try the land water, the 564. Okay. So I'd like to know which is the bare earth, the bare soil. Which is the bare soil? And let's try the 652. Okay. So from this we can see the lighter colors, the lighter purple can be classified as the bare soil. And then we've already classified one as agriculture. Okay, no, we haven't. We can use this, we can classify this as fields or agriculture or normal farmland. Let's go back to, okay. Let's go back to this. Okay, let's call it number 3. Fields. Can select our region of interest. Ouch, I didn't hold down Control, so it deleted the original one. Save that. Fine, so let's now go to our 4th macro class and select settlements. Built up areas. Can classify these ones as built up areas. So when you're done with your classification and identifying regions of interest, you go to your SCP tool, Remember, we're working with pre-processing. Now we go to band processing, classification. Our input band sets. See how we are working with band set 2, so change the figure to 2. Use class ID. So if you want to work with a classification where, if you want to your final classification to come out with only the macro classes, you can tick this or this. One thing I didn't do was to change the colors. You know, BSL should be a darker color, not this. Probably built up areas will be red, but that should be left for you. This is how to do it if you want to. So you just double click on the color. BSL, let's call it pink. Let's call settlements red. You can use the color wheel here. And just like that. So we go to our SCP tool, band processing, classification. Oh, it's already open. So select for algorithm, select maximum likelihood. And then what other settings do we need? Let's just preview it. So to preview what we've done, just click on these arrows. You might already have yours here. So activate classification preview pointer. All you do is click and it shows you a preview of what your final classification will look like in that region. To take a few seconds, as you can see, our blue is the built up areas. Oh, I thought I changed that. Our blue is the built up areas while this is the bare earth. Let's zoom out to areas where we have water bodies and see how it's classified them. Okay, so you see our water bodies here. We see this one for our vegetation, for forests. I want to check out the fields. So anything that's wrong here, you can easily come here to edit your training inputs and be sure to correct it before processing your land use land cover map. So when you're satisfied with your preview, run. Okay, the file name, we'll call it Spatial Data Hub. Do well to like the video if it served you properly, and then subscribe to my channel as I'll be bringing up a whole lot of good stuff. Perfect. So this is it. This is our image Spatial Data Hub. This is very rough. If I was to go back again, one major thing I'll work on is the colors. As you can see, the fields and the bare soil have very close colors. That makes it very nasty. And you can also see that the water bodies don't stand out. Water bodies don't stand out. The forests don't stand out very much from the bare soil. So do well to play with the colors. And if you also, sometimes you might classify certain features, and when your images, your pixels intersect with other pixels that identify other features, you have some features classified as others. So take a step back, edit your training inputs. To edit a training input, you can delete items from here. You can, if it doesn't work for you, you can simply uncheck it from your preview and then recreate it again to make sure that you have the best results. Of course, to export our layouts, you can create a layout and then export your image just the way you want it. Check the description of this video. It shows you a detailed preview on how to work on your layouts, and have fun with GIS, okay?